Next topic, half-range Fourier series. So half-range Fourier series, period 0 to L. The given function is defined in the interval 0 to L, open interval 0 to L, and it is immaterial whatever the function may be outside the interval 0 to L. You get the series of cosines only, that is half-range cosine series. We assume that f of x is even function in the interval minus L to L. That means we will make an even extension. So if a function is defined on 0 to L interval, we will extend this function as an even function to get a for half-range Fourier cosine series. So then we know that an must be equal to 2 by L integral 0 to L f of x cos n pi x by L dx, and Pn is equal to 0. And also we have a naught is equal to 2 by L integral 0 to L f of x dx. Okay. So then this series is called a half range cosine series, and it is of the form f of x is equal to a naught by 2 plus sigma n equal to 0 to 1 to infinity a n cos n pi x by L. That means there is no sine terms. Now, in order to get a Fourier sine series, to expand f of x as a Fourier sine series, we extend the function in the interval 0 to L. We will extend it to minus L to L as a odd function. So we will extend that interval into odd function. Then a n equal to 0, and we know that a naught must be equal to 0, and bn is equal to 2 by L integral 0 to 0 to L. We will generalize that 0 to L f of x sin n pi x by L d. So here the Fourier, then we call that this is a half range Fourier sine series, or simply sine series, or sine series. Okay, so the Fourier sine series is of the form f of x is equal to sigma n equal to 1 to infinity. We know that a naught and a naught and bn is equal to 0. So this will be bn, sorry, a naught and an is equal to 0. So bn sin n pi x by L. Okay. Then we will do a problem. So first find the Fourier sine series. So find the Fourier sine series for the function f of x equal to e raised to ax for 0 less than or equal to x, for 0 less than x less than pi. So here our f of x is defined, f of x equal to e raised to ax, and it's defined on the interval 0 to pi. So therefore here L equal to pi, and we want to expand it in terms of sine series. So for sine series, we know that a naught is equal to 0 and an is equal to 0. For sine series, a naught and an must be equal to 0. So only remaining thing is bn. So we want to find out bn. For before going to that, so bn, we know that by definition bn equal to 2 by L. L is pi, integral 0 to L. L is again pi, so integral 0 to pi e raised to x sin nx n pi x by L. Pi and pi get cancelled, so nx dx. So now, so we know that integral a e raised to x sin bx dx is equal to e raised to ax by a square plus b square a sin bx minus b cos bx. So this is the formula. So now we will use this formula to find. So this is pi by 2 e raised to ax a square plus n square into a sin nx minus, here instead of b n is there, so nx 0 to pi. Then we will apply the limit. If I put limit pi, you will get 2 by pi e raised to a pi a square plus n square a sin n pi a sin n pi minus n cos n pi plus n, and then I will um, apply the limit minus of 0. So if I put limit 0, you will get um, okay, e raised 1 by n square plus a square n square 1 by a square plus n square a sin 0 0 minus n cos 0 1. So what I will get is here 2 by pi e raised to a pi a square plus n square a sin n pi. Sin n pi is equal to 0, right? So this is equal to 0 minus n cos n pi. So we know that cos n pi equal to minus 1 power n for n, for all n. So we will get 2 by pi. You can take an outside n a square plus n square minus 1 raised to n e raised to a pi plus 1. So 2 by, so we will get 2 by n a square plus n square into pi 1 minus 1 power n e raised to a pi. So therefore we will get b1 is equal to, if I put n equal to 1, 2 into 1 plus e raised to a pi a square plus 1 square pi. b2 is equal to 2 into 2 1 minus a pi divided by a square plus 2 square, etc. So therefore the our so we can write e sin series in the sigma notation. E raised to ax is equal to sigma n equal to 1 to infinity. What is bn? Bn is this 2 by n a square plus n square pi sin nx. So this is the Fourier series, Fourier half range Fourier sine series or sine series expansion.